Welcome to the session. So in this session, we'll be discussing about the 2D viewing OpenGL functions. In the previous session, we had discussed about the two-dimensional viewing in OpenGL. Now we'll just see its respective functions, what we are going to make use of. So now when I talk about OpenGL functioning or the OpenGL 2D viewing functions, it is going to always work in two modes. That is the OpenGL graphics pipeline. What I just explained in the previous session, it is going to work in two modes. That is, now whatever the object design I do using the primitive points, line, polygon, segments, color, now all this we call this as model view mode. Fine. So now when the scene has been defined and decided, now I should see what part of the scene should be displayed and where should be displayed, as I talked about this viewing window and the viewport in the previous session. And so when I talk about a graphics pipeline, it's all about defining the scene, and later on you're going to decide what part and how it should be displayed. These are two modes what your graphics pipeline is going to always work. One is the model view mode, another is a projection mode, how we are going to project it. And now whenever you talk about any of the functions with respect to projection, with respect to viewing function, you need to be in the projection mode. And whenever you talk about the primitive coloring, all that case, you should be in model view mode. And that is what your graphics pipeline will always work in these two modes. Either you will be in the model view mode or you're going to be in the projection mode, and you have to switch between these two modes whenever it is necessary. If you want to design your scene, you need to be in the model view mode, and if you want to set the viewport, if you want to set the clipping window or the viewing window or any sort of projection operation, you need to be in the projection mode, and you should keep on shifting between these two modes whenever it's required. Hence, like operations, what I just told you, the primitive operation, the attribute operation, the transformation, what I apply for my object, all this is going to be under the model view mode. And if you're thinking anything about the clipping window, viewing window, viewport, normalization, all these things will be under the projection mode. Hence, when I want to shift to model view mode, I'll be using a parameter or a symbolic constant in OpenGL program called as GL model view, and the other symbolic constant GL projection. The symbolic constant will be used with the function called as GL matrix mode. Right now assuming I am in the GL model view, which is by default. Right now I am in the model view mode. So from the model view mode, I need to shift to the projection mode. If I want to shift or if I want to swap this mode, I am going to use GL matrix mode, and I am going to use this as a symbolic constant. And again, from this mode, if I want to shift back to the model view mode, then use the same function, and I'm going to pass the parameter as GL model view as a symbolic constant. Now this is what the two modes it's going to work always in. And when I use the GL matrix mode and GL projection, so by default your OpenGL system should load an identity matrix. This is what we say GL matrix mode, because in your OpenGL program and the graphics pipeline, everything is about the matrix operation, starting from identifying a point and later on putting a transformation or the viewing operation. Everything is going to be in the form of matrix operation itself. Hence right now, whatever the new projection you're going to set, you need to make sure you have been loaded with the identity matrix at this point of time. If there is no identity matrix, then whatever the old value the matrix add will be using that value with the new value what I want to set. And if that happens, then you may not obtain the actual view what you have designed or what you have been planned for. Hence, you need to make sure once I'm going to shift to the projection mode, you are going to have an identity matrix. The OpenGL system will do this, will do it by default, but there are certain scenarios where it may not happen. Hence, for that case, you need to use an API called as GLLoadIdentity. If I execute this API or this function, this is going to load the identity matrix for the current matrix. Hence, so whether your OpenGL program by default it does it or not, it's a good habit to call this API immediately after calling the GL matrix mode. And so when I call this function, the GL projection will be the current matrix now. Fine. And this will be an identity matrix. If it is not, still it is, then execute the GLLoadIdentity function. Now this function is going to load the identity matrix for the current matrix, which is going to be a projection matrix. Hence, this is what this two APIs is going to do in your program. And apart from this two program, so when I talk about any projection viewing, it was always a rectangular area for me. The clipping area was a rectangle area for me. Hence, that is what now I need to set. If I want to set the clipping window, if I want to set the viewing window, I am going to use the function GLUOrtho2D. And this is what I told you. The 2D viewing function or the 2D clipping window function is not in the core library of your OpenGL. Hence, I am using the auxiliary library called as GLU. So from the GLU, I am using Ortho2D. Now this is going to be orthogonal projection, not a perspective projection. Now don't worry about what is orthogonal projection, what is perspective projection. You will get clear picture about this only when you're talking about 3D viewing. If it is 2D viewing, there is no difference between an orthogonal projection and a perspective projection because everything is going to be orthogonal projection. Hence, right now, by default, 2D clipping window is going to be always a orthogonal projection. Hence, I am going to use the function GLUOrtho2D, which takes 4 parameters. That is, W is going to stand for clipping window or window coordinate. Hence, XW minimum, XW max, YW minimum and YW max. So using these two opposite diagonal corner points, I am going to draw a rectangle. So just recall how we are going to draw a rectangle by just using these 2 points which I discussed the API and talking about the polygon and how to draw a polygon or a rectangle specifically. Fine, so now we are going to have GLUOrtho2D, which is going to give me orthogonal projection. Right now, don't worry about this. We'll see it what orthogonal projection is later on. But right now, if I want to set a clipping window, this is the API, the function which I'm going to use. Now, for example, if I'm going to talk about GLUOrtho2D, so if you have any confusion this, even you can say it as left of the clipping window, right of the clipping window, the bottom and the top. That is what we are going to say. The first parameter is left, the second parameter is the right, the bottom and the top. Even I can name in this way. And if I am going to call the GLR2D as -1, comma +1, -1, +1, this is what the coordinate system will look right now. I'm going to have -1 at the -x-axis, +1 plus x-axis, and this is supposed to be, there's going to be a mistake here, so please correct it. Now this is going to be +1, this is going to be -1 because bottom is -1, this was supposed to be -1, and this entire axis, y-axis will be 2 units and the x-axis will be 2 units. Starting from -1 to 0 is 1 unit, 0 to 1 is the second unit. Hence, I can set any clipping window now, any coordinate system or the coordinate value by just changing the parameter values here. I can give negative value, I can give positive value, I can give any value here now. This need not be always the same value. You can set your coordinate system on the clipping window passing any parameter of your choice for this function GLU Ortho2D. Fine. So now once we are going to have the clipping window, the next thing is you need to have a viewport. You need to set the viewport. And to set the viewport, I am going to use the function GLViewport, which takes 4 parameters. The first 2 parameter is the bottom left corner of the viewport. And the next parameter is what is the width you are going to set. And the 4th parameter is what is the height you are going to set. And so now it is similar to the rectangle what we have just discussed, which I need 2 diagonal opposite points to draw a rectangle. The viewport is similar to that. Hence, if I want to know what is XV max, I am just going to have XV minimum plus width will give me XV maximum. XV minimum plus height will give me XV maximum. Hence, you need not worry about this. When I talk about viewport, just pass these 4 parameters which will create me a viewing window now. So which is going to be a viewport decides where this should be displayed. And so now by default it is the window size. If you don't have or execute this API, then by default the entire your display window is going to be the viewport by default. Fine. So now we are going to have viewport. So now once we are going to have viewport, if you want to know what is the viewport has been currently set, if you want to fetch the current viewport information, that is where the viewport has been defined, what is the width, what is the height, then you're going to use the API called as GLGetIntegerV. We're going to use the API GLGetIntegerV, where we are saying GL is the OpenGL library. Get is I want to get the values in the form of integer and I should put it into a vector or an array. That is what this function name stands. Right now I want the GL viewport function, and the first parameter is what information you require. I do require the viewport information, as the first parameter is going to be the viewport, and the output of this function will be stored in a vector or an array. And so I'm passing an array now, and now whatever the array you're going to pass now, make sure this is going to be size of 4. This is going to be single dimension array with size of 4, because upon execution of this function, the very first value in this array, that is VP array of 0, will be having XV minimum, VP array of 1 will be having YV minimum, VP array of 2 will be having the width, VP array of 3 will be having height. Hence this array will contain the same 4 information what I used to set the viewport. Now I am going to see what the current viewport has been set. I can fetch the information of the viewport using this API. And this is how we are going to use the APIs whenever you want to set the clipping window, whenever you want to set the viewport, and whenever you want to get the information of the current viewport. And all this operation should be applied for the projection matrix, and I will make sure the projection matrix is loaded with the identity matrix to perform any of this operation. Now with this function, viewing function, now I should discuss about the display window functions. You are already aware of these functions as the basic API. Now we'll just have a relook into this. Now the very first API, whenever you're going to talk about display window function, is I'm going to use GLUT-init function, where I'm going to take the command line argument from the main function and I'm going to pass it as a parameter for this. So now this API should be executed because your Windows system has got its own window management system. Now my program should be one window among this. Hence, I need to initialize my program to work with this windowing system in the given computer system. Hence, for this case, I need to execute this API GLUT-init. So once this is done, I am going to create my window, and while creating my window, I should tell starting from what position my window will be drawn. Now just assume this is the entire monitor, which is going to be 720 by 480 pixels. Now in this scene, I am going to decide that I need to have, this is the point where my window should be drawn for visible. This 50, 60. Hence, I am going to call this function GLUT-init window position. X top left is going to be 50. Y top left is going to be 60. Now, starting from this, I am going to draw a window. Hence, we call this as top of the window and left X value. Top of the window, left Y value. This is, I'm going to set where the window should start drawing my window. Hence, now if I give -1 comma -1 as the parameter, this is going to use the default point whatever your current system is going to draw the window. If you want the default point of your current system, just use the parameter as -1 comma -1, or do not call this API at all. If you want to use the default point position where your window should be drawn. And so once you have decided the point, the next thing is what is the window size is going to be. So now I can decide what is the height of the window is going to be and what is the width of the window. What I'm going to draw is going to be starting from this position. Hence, I'm going to use the API GLUT-init window size, where I'm going to pass it as 500, 600 is the width is going to be 500 and height is going to be 600 now. And you can pass any value of your choice what it's going to be for this function. But if you give more value than the width of your monitor, then it will go outside the monitor as a view. And so make sure the value what you're going to give will fit into your monitor window. And if you want the default size, just give it as -1 comma -1, and at OpenGL program by default the size of the window is 300 comma 300. Fine. So now with this function, now I am ready with where the position should be of my window, and I have initialized that my program is going to work along with the windowing of the computer system, and what the size of my window is going to be. Now I am going to create the window. And while creating the window, I am going to give the title of my window what it's going to be. And so this is the window what I am going to create, and the title what I am going to give is my window. Now this is how we are going to create the window on your computer system. And so now once this is done, now my window has been designed and it has been viewed now. Now whatever should be drawn inside this window, whatever the picture description I am going to put inside this window or onto this window, you need to use the callback function called as GLUT display function. This API is going to call a callback function with the name picture description wherever the picture description is going to be. That is, I am going to now, for example, I am going to use this function to call a draw function, and you need to make sure now draw is going to be a callback function which takes no parameter and which returns nothing. Hence, I am going to have a function, a user defined function called as void draw, which takes no parameter and which returns nothing. And this function name can be anything. It need not be draw always. It's a user defined function. It can be anything. And this function, I'll be passing it as a parameter. And so now when I execute this function, when I call this function, whatever the code I'm going to put here will be drawn on your window. Now if I want a square over here, you need to make sure the set of APIs what I use to draw a square, I am going to put inside this function. Yes, now in general, this is going to be a display callback function which takes the function as void. It can be any function name and takes no parameter, returns nothing and takes no parameter. The function name can be anything. Now this is how we are going to use GLT display function. Now once all this is set, you need to trigger the execution, or you need to have the starting point of the execution of your program or OpenGL execution. That is what we start with the GLUT main loop API, start of display process, and which will be in a continuous loop. Hence I need to make sure I am going to have GLT main loop function also. Now apart from these basic APIs, we are going to have a window. Now I have been set the position, I have been set the size, I have been drawn the window with a title, and even I am able to put something into this window, and even I am able to initiate the execution of the process which can be in the loop. Now this window can work in different modes. This can work using a single buffer or work with a double buffer, and even this can work in different color modes. It can be the RGB color mode or it can be the index color mode. So by default your window, if you don't use this API, by default it is going to work in single buffer and RGB mode. Hence that is the mode what I am going to pass as a parameter. And now if I want the single as the default, I am going to use a symbolic constant GLUT single, and using the XOR operation I will be using GLUT RGB. And so now my display window will be working in the mode of single buffer and RGB color. Or else if you want, you can use the index color also. Instead of RGB, I can use the index color and the single buffer, or I can use the double buffer and being in the RGB mode, or I can use the double buffer and the index color, or I can use the RGB color model, the double buffer. Out of this double buffer, one buffer will be dedicated to the depth buffer. And if you are working in a 3D environment, you need to make sure this is going to be the mode of your display window. And if you are working in 2D environment, then this mode is sufficient for me with the single buffer. And so now you decide in which mode your graphics window is going to work using the function GLUT init display mode. Hence now with this function, the next function is we are going to use GLClearColor. That is, now by default the background color of your display window is going to be black. By default it is going to be black. So now if I want to set to any other color, I am going to use GLClearColor. Hence, so now I am just going to use GLClearColor, and now I am going to set the color for 0, 1, 0, 1. That is, the red is 0, green is 1 and blue is 0. Hence my desktop or my window background will be set to green color. So right now don't worry about this alpha value. This is something to do with the transparency. We'll think about this later, but right now the fourth parameter, keep it always 1 by constant. Just look at the remaining first 3 parameters. Now this 3 will decide what color you're going to have the background of your window. Hence, so now if this color should be applied, now once I execute GLClearColor, this is going to only set the color. This will only set the color. Remember this. And if the color which have been set, if it wants to be applied to your window, you need to use GLClear function. Now this GLClear function will clear all the pixel bit to the desktop background color, and currently the desktop background color is going to be green. Hence for this we are going to have the complete background of your window is going to be of the green color. This is how we are going to use the clear color and clear. And now, as we have already seen how we are going to create a window, now this API will create a window, as well as if you want, if it is necessary, this function will return the reference of the window also. Using the reference, you can work with the multiple windows. And so now whenever you want to work with the reference of your window, you can use GLCreateWindow, and you can use the assignment operator to store the reference of this. You can store the reference of GLCreateWindow, and later on, if you want, you can make use of this. And how to use this? So hence, remember, GLCreateWindow can be used to just create the window, and you can ignore the reference of the window. If you want to work with the window with the most strategic way, you can hold the reference in a variable. And so now once if you are going to have a reference, now these are the few things what you can apply in a window. If you want, you can kill the window or destroy the window by using the reference of your window. If you don't have this reference, you cannot kill it using API. You need to do it the hardware window close. And so if you are going to create multiple windows, right now this is going to be one window. Similarly, if I call the function again, this is going to create two windows. Hence, you can hold both the reference, and you can currently say which is going to be the current window by saying GLUT set window and just pass the ID of the window. This is going to set whatever the ID you pass as a parameter as the current window. And if you want to know which is the current window, in case if you want to know which is the current window, just use the function or API GLUT get window. This will return the reference of the current window whichever currently is going to be on the foreground. And this is how we are going to use the create window APIs and a few functions to manage the window or the display window functions. Now with this APIs, now just look at this, the window position what I already add. Now we had set the position to say where the window should be drawn. Being in execution, if you want your window to be at a different position, then you can use GLUT window position API. GLUT init window position will initialize the initial position of your window. Later on, whenever in between the program, if you want to change the position of your window, you can use GLUT position window. Now I can give the new top left value and new top left Y value. Fine. So we are going to use the API to give new position. And if you want to change the size of the window in between the execution, I am going to use the function GLUT reshape window. This will initialize the initial size of your window, whereas this function can reshape your window. Hence, I am going to give the new width and I am going to give the new height. This is how we are going to use the GLUT reshape window function. And just if I want the window to be the complete screen, if I want the complete screen of my window, then I'm going to use GLUT full screen. If you are executing this API, whatever the parameter you have passed with GLUT reshape window and init window size will be ignored and will be overlaid, and I'm going to get a new size which is going to be equal to the complete monitor size. This is how we're going to use GLUT full screen. Now just look at this one more property here. So now whenever I'm going to have my window and I have been drawn a square, and now as you are aware now, you can change the size of the window, and now if I change the size, I'm going to keep the height intact and I'm going to increase the width. Now just look at the difference what has happened. So now in this case, I add a square, but due to the enlargement in the width, even my object has been enlarged. Here my object was square, now it becomes rectangle. But even if I change my window, if my object should not be destroyed or destructed, in that case I am going to use GLUT reshape function, and I am going to pass the callback function which is going to make sure my object will be intact. So if you don't want such distortion to be happened to your object upon the change in the size of your window, we are going to use GLUT Reshape callback function. So remember, don't get confused. So GLUT Reshape window is used to resize the window. GLUT Reshape function is used to make sure you're not going to get a distorted object upon calling a callback function. Now this is how we're going to use this set of function to manage the window. So now just look at this. When I'm going to create a window, inside this window I can create a sub window also. I am be able to create sub window also. I'll be having multiple windows, 2 independent windows which I can do using GLUT create window, or I can have a second window as a sub window inside the main window itself, in the same window itself. And this I can do using GLUT create sub window, where the first parameter is the window ID to which I need to create a sub window. If this is the window which I want to create a sub window inside this, now the ID of this window should be passed as first parameter. And next I am going to give what is the bottom left X value, bottom left Y value of the new sub window, and what is the width and what is the height of this window. Hence I am going to create a new sub window. Now this new sub window is going to have, this is going to be the bottom left and the bottom Y value and the X value and the width and the height. And now you need not give any title for this. You are not supposed to give any title for this. Only for the explanation purpose I have used here, but you are not supposed to give any title for this. You will be having the title of the main window itself will be the reference for this. Hence you cannot give any new title for the sub window. Remember this. And even there won't be any icons which you can work on the sub window, because this will be embedded for the main window. Hence the main window will be controlling this sub window. Hence remember how the sub window will be created in your program. And this is how we are going to use the GLUT create sub window in your windowing function. And next, so you are aware that when I were working with any of display system, you can have different types of cursor design. That is, the cursor is busy, you cannot use the click over here, or you can drag, you can enlarge, you can zoom, you can wait. Hence there are similar or different ways of pointer what I can use. And in OpenGL program you don't have all these options. I have just put over here just to make sure you understand what is the cursor design looks like, or what this cursor design is. In your OpenGL program there are 4 types of cursor what you can use. Apart from the default cursor what you are seeing right now on your display device, apart from this I can use a cursor which is going to be up down. So which is going to be both up and down cursor type I can use. If I pass this symbolic constant as a parameter for this function, then whatever the cursor I'm going to get is going to be up and down. Or I can have the cycle. I can have GLUT cursor cycle, something like this. If I want this as my cursor design, I am going to pass this as parameter. And if I want to wait, if I want to have this as the cursor or the wristwatch design as a cursor, I am going to pass this as a parameter for this as GLT cursor wide. And if you want this cursor, or if you want the skull as your cursor design, I am going to pass the parameter as GLT cursor destroy. Now I can have different design or the different types of cursor on your display when you're going to work with the window. And later on, whenever you're going to have any modification in your scene, and immediately if you want to update it, I'm going to use GLUT post read display function. So I can call the GLT post redisplay function whenever you think immediately you need the modification or updation on your display device, whatever the description you have put, whatever the picture description I have put. Now this display function will be called whenever there is a refresh cycle or whenever a change in the display should happen. If I want to trigger the change to happen, I need to call the API GLT post read display. Upon execution of this API, this is going to trigger or calls the display function API, and this is how the GLT post read display is going to work. And now once your program has been done with the execution, it is going to be in the idle state, and whenever your program will be in the idle state, now this GLT idle function will be immediately triggered, and you can call any callback function in this. Whenever your program does the display operation, once the graphics pipeline has been done its job, your OpenGL program will go into idle state. And once it goes into the idle state, you need to make sure, or you can make use of this API to think what you can do when your program will go into idle state by using GLT idle function. And so the set of APIs what you can use with your display window or what you can use with the viewing functions, and it's just an example program how we can make use of this set of APIs. Now just look at this program what we have done here. Let us start with the main function. So I have got command line argument. So using GLUT in it, I am going to pass the command line argument address of the parameter. And now you know what this is going to do. This is going to initialize the windowing operation with the Windows system. And once this is done, I am going to set the display mode. The display mode should be the single buffer and the RGB color model. And the position of the window is going to be at 50,50, and the size of the window is going to be 600,300. That is 600 in the width, 300 is going to be the height. And I am creating my window, and the title what I am giving is split screen example. And I am going to have a user defined function here as my init. So where the my init function has got few more APIs. So where I am using the API GLClearColor, which is going to set to what color my display should be. Right now I have set all RGB to be 1, hence my background is going to be of white color. And the last 4 value is 0 or 1. Right now it doesn't matter because I have not activated any transparency operation over here. And next we are going to have GL matrix mode, because I need to shift from the model view mode to projection mode, and say I'm using GL matrix mode, GL projection. I am shifting to projection mode because I am setting the clipping window. I am setting the clipping window using GLU Ortho 2D as -100, 100, -100 and 100. Hence minus X will be -100 and plus X will be 100. So totally I'll be having 200 units over here. The minimum value will be -100. The maximum value is going to be 100. This is how I'm going to set the clipping window now, or the coordinate system to work in my application. And I'm making sure that whatever the projection matrix currently I'm going to have, I'll be loading this with an identity matrix. And so once I have been set the clipping window, once the projection is done, I need to switch back to the model view. Hence I will be calling GL matrix mode and GL model view. So when all this API is done, I will get back to the main function. So in the main function, if I want to put any picture definition onto my display device, I am going to say GLUT display function. And this is what happens. I am going to create the window as split screen example, and I am going to set this is going to be the clipping window, whatever I am going to have as GLU Ortho 2D. This entire thing is going to be -100, 100, -100 and 100. And now once this is done, I am going to call the display function, and display function is going to call the draw function. And in the draw function, I am identifying the 3 points. To draw a triangle, I am identifying the 3 points in the given coordinate system. And I am going to clear the background now. I have been set the background color using this API. I am going to clear the background now. And I am going to set what color I am going to draw the object. Right now I am going to use the color blue whenever I want to draw an object, because this is going to be the blue component. And now I am going to set the viewport as 0, 0, that is the bottom left corner 0, 0, and the width is going to be 300, height is going to be 300, as this is going to be 0, 0 for the viewport, and this is going to be the 300 width and 300 height, as this is what the viewport is going to be now. Whatever the dashed rectangle we have drawn here, this is the viewport what I have been done. And using this viewport, I am going to draw a triangle by calling or by passing this 3 points as a parameter. Hence now the triangle will be called by passing the 3 points and using the GLBegin to draw a polygon as triangle and passing this 3 points. So this you need to understand how I am drawing a triangle here. And once this is executed, I'll be able to flush it out onto the display, which I am going to see a triangle on the display, and GLUT mainly will initialize this entire execution, and this is how the program is going to work. So now what if I am going to modify the program where I am going to have the color I am going to change to red, and I am going to change the viewport now. The viewport what I am changing is the starting point is going to be 300, 0, that is the bottom left corner of the viewport, and the width is going to be 300, height is going to be 300. That is the new viewport I am setting. If I execute this viewport, I add the earlier area of the viewport of the view, and this is the new viewport what I am setting. And I am going to rotate the object by using the rotation 3D function with 90 degree and with respect to Z axis. And again I am going to call the same triangle function with the same point. I am not changing any points over here, but I have been changed the viewport. This is where now the viewport decides where in the display the object should be displayed. Hence this viewport displayed the blue triangle in this area in the old viewport, and the red triangle with the rotation of 90 degree has been drawn in the new viewport. Now this is how we are going to make use of the viewing function and the window function to have an OpenGL program. And this is all for this session. Thank you.